Okay, folks, let's continue our discussion of chemistry so that we can understand better how drugs work. And today we'll be discussing periodic trends, okay? So we're going a little bit deeper into what the periodic table can tell us. We'll talk about electron configuration, atomic radius, and electronegativity. So last time we were together, we talked about, what can we learn from the periodic table? But there's more than just atomic mass, groups, and periods. We can understand a lot about the properties of any given element just by understanding where it is on the periodic table. So let's jump into it. Let's start by discussing electron configuration. And to discuss electron configuration, we need to go a little bit deeper into discussing orbitals. Last week, we talked about how electrons are outside of the nucleus in electron orbitals. But what is an orbital? So I think of an orbital as the space that we will most likely find the electron. And there are a lot of different types of orbitals with a variety of shapes. So shown to you folks on this slide are pictures of different types of orbitals. We have some very simple orbitals that look like this sphere. That is the simplest type of orbital that you might think about. And this orbital is called an s orbital. So I'll just draw it a little bit bigger so that you can see it, even though it's in the graphic. An s orbital, very simply a sphere. So you can understand that how within the sphere, the electron could bounce around. The next type of orbital are the p orbitals. And so the p orbitals look like dumbbells. And there's three types of p orbital that are dumbbells either kind of on the x-axis, the y-axis, or the z-axis shown to you here. And so this shows you some additional space that electrons are likely to be found in. And then we just get more and more complicated, folks. There are all sorts of d orbitals and even more types of f orbital. But what we should understand is that an orbital is the space where we are most likely to find electrons. And specifically in chemistry, folks, we know that electrons always come in pairs. So we're not just talking about a single electron, we're talking about the space where we will most likely find two electrons. How do we know which type of orbital an electron might be in, s or p, for example? Well, all of these orbitals, you could kind of line them up based on their energy level, okay? Some are super low energy, some are super high energy. And the rule of thumb is that electrons fill starting at the lowest energy one, then go to the next highest energy, then the next highest energy, etc. And this generally aligns with the shape of the periodic table, which we'll get into in a moment. So, looking on the right-hand side, folks, I have a diagram showing you how energetic the various orbitals are. So the very first orbital that's going to be filled is going to be the 1s orbital because it is the lowest energy. If we go to the next highest energy, we see 2s, so that'll be filled second. Then the next highest energy is not 3s, but 2p. You can see how 2p is lower energy than 3s, so it would be filled third. And on, folks. 3s would be fourth, 3p would be fifth. Becomes a little bit more complicated when we start to have a d orbital. Up until now, we've kind of been going sp, sp, right? The next highest orbital from 3p is 4s. That's easy enough, so that would be sixth. But now you can see that 3d is actually lower energy than 4p. That means that 3d is filled next, so 3d is seventh, and 4p then would be eighth. But you see here, I'm just following the rule of filling from the lowest energy. Up next, I'll give us maybe a bit more simple way to use the periodic table to determine how orbitals are filled.